Mastering programming languages for cybersecurity. 5 essential languages every hacker should learn. The world of hacking, whether ethical penetration testing, malware analysis, or exploit development, demands fluency in specific programming languages that enable security professionals to manipulate systems, automate attacks, and build defensive tools. While many languages have applications in cybersecurity, 5 stand out as particularly critical due to their versatility, low-level access, and prevalence in security research. Python reigns supreme as the lingua franca of hacking, prized for its readability, extensive libraries, and rapid prototyping capabilities. Ethical hackers leverage it for scripting custom penetration testing tools, using Scapy for packet manipulation, requests for web interactions, and Socket for network programming, automating repetitive tasks, and developing proof-of-concept exploits. Its dominance in cybersecurity stems from frameworks like Impacket for network protocol attacks and PlanTools for exploit development, combined with seamless integration into tools like Burp Suite for web app testing. Python's role extends to malware analysis through libraries like pfile for examining Windows executables, and forensic investigations, making it the most versatile first language for aspiring hackers. For low-level system exploitation and reverse engineering, C and C++ remain indispensable. These languages provide direct memory access crucial for understanding buffer overflows, heap corruption, and other memory-based vulnerabilities that dominate critical security flaws in operating systems and embedded devices. Ethical hackers analyzing malware or writing kernel-level rootkits must comprehend C's pointer arithmetic and memory management, while C++ object-oriented features appear in sophisticated malware employing polymorphism to evade detection. The majority of legacy systems, IoT firmware, and operating system components, Windows Linux kernels, are written in C/C++, meaning security researchers dissecting these systems need fluency to identify zero-day vulnerabilities. Tools like GDB, GNU Debugger, and Radar 2 for reverse engineering rely on C's semantics, while exploit development for embedded systems often requires writing shellcode in C to bypass protections like ASLR, address space layout randomization. JavaScript dominates web hacking. As the backbone of modern web applications, understanding JavaScript and its Node.js runtime is non-negotiable for identifying cross-site scripting vulnerabilities, manipulating DOM-based attacks, and reverse engineering AJAX-driven applications. Hackers use JavaScript to bypass client-side security controls, exploit insecure deserialization in web APIs, and craft malicious payloads for phishing campaigns. With the rise of Electron-based desktop apps like Slack and VS Code, JavaScript vulnerabilities now extend beyond browsers into standalone software. Tools like Burp Suite and OWASP-Zap rely on JavaScript analysis for web app testing, while advanced attackers weaponize WebAssembly, a low-level JavaScript alternative, to create stealthier browser exploits. For network-level attacks and protocol analysis, Bash scripting and its Unix shell variants like Zush provides unparalleled control over Linux-based penetration testing distributions like Kali. Ethical hackers use Bash to automate reconnaissance, combining Nmap, WHOIs, and Digin pipelines, manipulate packet flows with IP tables, and deploy post-exploitation scripts across compromised systems. Its simplicity in writing one-liners for privilege escalation, like find /-perm-4002 greater than dev null to locate SUID binaries, makes it ideal for real-time system manipulation during red team engagements. Bash's integration with Linux toolchains, such as awk, sed, and grep, allows hackers to parse logs, filter network traffic, and chain commands for sophisticated attacks, skills critical for operating in environments where GUI tools are unavailable. Finally, SQL, or Structured Query Language, is mandatory for database hacking. Understanding SQL syntax enables ethical hackers to detect and exploit SQL injection vulnerabilities, the most persistent threat in web applications according to OWASP. Attackers craft malicious queries to bypass authentication, exfiltrate sensitive data, or execute arbitrary commands on database servers, using techniques like union-based attacks or blind SQL injection. Knowledge of database-specific SQL dialects like MySQL, PostgreSQL, and MSSQL helps in advanced attacks, while defenders use SQL to harden databases with proper parameterized queries. Tools like SQLmap automate SQL injection exploitation, but require underlying SQL knowledge for manual bypasses of web application firewalls. Beyond these 5 specialized languages like PowerShell for Windows-based attacks, Rust for developing secure memory-safe exploits, and Go for writing cross-platform malware are gaining traction, but Python, C and C++, JavaScript, Bash, and SQL form the foundational toolkit. Mastery involves not just syntax, but understanding how these languages interact with systems. Python for rapid tool development, C and C++ for low-level exploitation, JavaScript for web manipulation, Bash for system control, and SQL for database breaches. Ethical hackers combine these languages creatively, using Python to fuzz a network service analyzing crashes in C, injecting JavaScript into web apps, automating cleanup via Bash, and dumping databases with SQL. As cybersecurity evolves, these languages adapt. Python integrates AI for threat detection, JavaScript expands with Web3 vulnerabilities, and C++ appears in next-gen ransomware. The true hacker's edge lies in selecting the right language for the task while understanding the underlying systems they exploit or defend.